Okay, so in this video, we're going to be turning the finite state machine we worked with last time into a state table and then into an excitation table. And then depending on time, we'll try to either start the circuit or we'll see how it goes. So a state table, what it contains is it has the current state, it has an input that the current state kind of takes in. And for this, we kind of use the dotted line because they are really similar. They're kind of one type of thing. And then on the other side, we have the next state because we're concerned about where one of these state goes next. So we need next state. And then we need the output. So this is a meeting machine, so our output, as we will see later, will depend on the both the input and the current state. So for current state, we're just going to label them. This x we'll call S0, this we'll call S1, this we will call S2, and this we will call S3. So for our S0 state, it can take in an input of either 0 or 1. And on input of 0, it will go back to itself, so the next state will be S0, and it outputs A0. Fairly simple. So for input 1, it will go to state S1, and it will also output a 0. And then for our next one, we're going to do the state S1. So for state S1, it's going, when it takes in input 0, 0. When it takes in input 0, it'll go to state S0. That's where this transition leads. And it'll output 0. And when it takes in 1, it'll go to state S2, because that's where this transition leads. And this will output 0 as well. Next, we'll talk about state S2. As you notice, all the states only has 2 inputs because there's only 2 inputs possible. So when you take in a input 0, we will go to state S3 this time. And the output will be 0 as usual. And if you're taking a 1, then we stay at the current state, which is S2, and output 0. Next on S3, fairly similar, 0 and 1. On input 0, it goes back to the first state, so that's S0, output of 0. And finally, on input of 1, it goes back to S1, and it outputs a 1, finally. So this is a state table. And if you were listening earlier, we talked about making this, also making an excitation table. So what that excitation table is state table with state assignment. So for now, we're holding these states, but there's really no way for us to represent it in a binary way. You don't want to have to represent a binary S or a binary 0. But what we can do is represent these bits with actual binary bits. So we will have another lecture to talk about bit assignment. So now to actually do state assignment, what we need to do is we need to determine how many bits we need. So we have 4 states, and we know that for every bit we have, we can encode 2 to the that many states, because every bit can either be 0 or 1. That's 2 possibilities for each state. We have 4 states here, so we need 2 to the something to encode 4 states. And that happens to be 2, which means we only need 2 bits. So For us, we're just going to use a simple binary assignment with 0, 0, 0, 1, 1, 0, and 1, 1 as the state assignments. And let's temporarily delete this so we can write our excitation table. So now let's actually build the excitation table. So for the excitation table, we still have current state. The labels are still going to be very similar, except for current state, we need 2 state bits. And if you remember for a D flip-flop, this is D, this is Q, we output the current state, right? So we use Q1 to represent the most significant bit, and we use Q0 for the least significant bit. And then we still have input. That's going to be the same. And then we have one line down. And then here we have next state. And remember that next state is stored in the D flip-flop, so we can use D for this. And then we have output. So input is going to be 0. Ooh. So this is kind of a line here. Next state is going to be denoted by D1 and D0. So for this, we start with 0, 0, and the inputs can either be 0 or 1. This is basically going to be a copy over from the other table, except for every state we're going to replace with the actual state bits. For state S1, we're going to replace with the state bits 0 and 1, and the outputs are still going to be the same. And for state 0, 1, here we'll do, for state S1, we'll do 0, 1, and then the inputs are still the same. This will go to S0, which is 0, 0, and then it goes to S2, which is 1, 0, and then you still have 0, 0. Then you have 1, 0 for state S2, taking 0, 1, and then here it goes to S3, which is 1, 1, and it goes to S2, which is 1, 0, both output zeros. And then you have state S3, which is 1, 1, input 0, 1, and then it goes to S0, which is 0, 0, and it goes to S1, which is 0, 1. And then one of these, the second one, when it goes to S1, it outputs a 1. So in the next video, we'll turn this into an actual circuit.